Yeah, so the major focus of our lab has been historically the study of light chain amyloidosis, which is an orphan disease, a rare disorder, and it's basically the overproduction of a protein called immunoglobulin light chains by monoclonal plasma cells that are in the bone marrow, and that protein gets secreted. It's normally a component of an immunoglobulin, an antibody, but in these patients, the light chain gets produced on its own in large amounts. It enters the circulation, and then for reasons we don't yet understand fully, it aggregates into these protein fibrils, which are the amyloid fibrils. They deposit in organs and tissues, and just the mass of this deposition causes dysfunction in the organ and eventually failure. And it can affect any organ or tissue. The heart and the kidneys are the most prevalent and the most disastrous with respect to diagnosis and prognosis for the patients. But any organ or tissue can be involved. It's a very heterogeneous disease, and it's been difficult to appreciate because of that, and because we haven't been able to image the full extent of the disorder, where the amyloid deposits actually are, and how they can completely impact the patient. And, with respect to AL amyloidosis, there's no genetic predisposition that we're aware of. Environmentally, there's no environmental factors that we've been aware of that are associated with it. It is more prevalent in African Americans, but only by a small degree. And so it seems to be a random event, generally of people in their 60s and 70s get it most. It's similar to multiple myeloma with respect to the disease pathology, and many of the treatments historically have come for AL amyloidosis have come from the multiple myeloma patient population and the hem-onc groups. And these patients are treated primarily by hematologist oncologists. And so the idea is that they attack the plasma cell clones that produce the protein, and that's the similarity. But it can impact anybody. Thankfully, it's rare because it is quite devastating.